Hey there. So this is a video about the midpoint rule and an application of it. In this case, Rashid is running in a virtual half marathon since he can't run in a regular half marathon. His friend Jeff rides behind him on a bicycle, social distancing, all that. And Jeff clocks the pace of Rashid every 15 minutes. Rashid starts out strong, but after an hour and a half, he is exhausted and decides to stop. I'm kind of with him there. The data collected is listed below. So I have this table here. So the time, I converted the time to hours already, so we don't have to worry about the scaling and converting minutes to hours, although there might be a problem in which that is the case. The speed is in miles per hour rather than in units per minute, so all the units are correct. So as you can see, as I move this up a little bit, he starts off pretty strong with a 0 right there. At time 0, he's starting off really fast at 12 miles per hour, keeps on going, and every 15 minutes, and then he comes to a dead stop after 90 minutes, which is 3/2 of an hour or an hour and a half. So the goal here is to estimate the distance that Rashid ran using the midpoint rule. So remember, the midpoint rule is not the left and not the right. That's kind of obvious on that. But it is actually something that is in between. So the left-hand rule and right-hand rule can sometimes both have errors in them. Midpoint rule takes the average point. So the X value is in between that you're trying to find using that. So first question is, how many subintervals can we make? And this is, of course, using the midpoint rule. So let's take a look at that a little bit more carefully. So if we see here, we have 1, 2, 3, 4, 5, 6, 7 time intervals. So it's the initial one plus 6 more. So if we were doing the left or right hand rule, we could just say, well, 0 to 1/4 was an interval, and then so on and so forth. The problem is the midpoint rule, we need to know what's happening in the middle of each interval. And we only have a discrete number of points. We don't have a continuous function like we do in a lot of problems. So the best we can do is say, for example, in this first interval, what I can do is I can choose this point right here. So that's halfway in between. So, but that's the entire interval 0 to 1/2. And then I could choose another interval, this interval to that interval, and choose the point in between. And then the third interval, that's the point in between. So I can use the endpoints of each interval are going to be the same, but I can't just say 1/4 to 3/4 of the interval because you can't have intervals overlapping. So the best I can do is have 3 subintervals that I can make, and that's about it. What is the width of each subinterval? Well, let's take a look. So based on where I made the points where I'm going to have a midpoint, it seems to me that I'm going from 0 to 1/2, for example, and it continues in the same pattern. So the width of each subinterval is 1/2. Now, some people, it's pretty easy in this particular case to just sort of visualize it from a table, but you can also use kind of our standard technique. And so the difference in this case, it's going to be, I'm going to use delta t rather than delta x because t for time. So I can call this time instead of x. And we know usually we call it b minus a over n. Now remember that b is the rightmost endpoint, which in this particular case is 3/2. The left-handmost endpoint is 0. And we have 3 subintervals in this case, so n equals 3. And 3/2 over 3, that's going to give me my 1/2 back again. So that matches exactly what we saw just by looking at the table itself. So you can actually do this either way. I think it's easier to just look at the table, but some people like to do it using formulas. So that's okay in general. So that works either whether you have a table or you have a function that you're trying to do. So with that, at what points do we take the velocity? So if you remember from the table, I'll go right back up, we have time and speed. So I did speed instead of velocity, but it's going to be the same thing here. And so the question is, at what points do we take it? Well, it's the midpoint of each interval. So it's going to be t equal, the first one is t equals 1/4, which is halfway between 0 and 1/2. And then it's going to be every half an hour. So 3/4 and then 5/4. Yes. Okay. And it's 3 subintervals. So it's going to be at 3 places that we use the midpoint rule. So that's it. Now we need to approximate the distance. And so we have to remember how we're going to do that. So the distance, and I'm going to use approximately equals to. We have to be really careful because it's not going to be the exact distance. So you definitely need to be careful about using the right notation. So midpoint rule, a lot of times people use a capital M for midpoint rule, and it's going to be sub 3. So this means I'm using the midpoint rule with 3 subintervals. Okay, I'll even write that down since some people like to see that. And you can think of it, remember, a subinterval is just where you're taking the rectangle. Okay, so now I can use exactly equals because of that. So it's going to be f at 1/4 times 1/2. So remember, that's the value of the function that you're taking. That's the height or the length, if you like, and that's the width. Oops. Don't know how that happened. And then you continue adding the same way. And we already wrote down the values that we're going to take it at. If you remember, we said 1/4, 3/4, and 5/4. So that's where we're going to take it again. So to double check what those values are, I need to go back to my table. And if I check, it's 11, 10, and 4. So it's 11 times 1/2. Plus 10 times 1/2 plus 4 times 1/2. So this is going to be 5.5 plus 5 plus 2. So that's going to give me 12.5. And it's better if you do use the units. Remember, that's going to be in miles, which is really too bad for Rashid because a half marathon is about 13.1 miles. So he wasn't that far away from actually finishing the half marathon. So too bad for Rashid. Next time.